Greetings, my devious decimals. We're going to continue the topic of converting decimals to fractions. This time we're going to do it for repeating decimals. So decimals that repeat and they go on forever. Now we're going to start off with an easy-ish example because we might even know what the answer to this one is. 0.333 repeating. So there are three ways that we can represent this. We can do 0.333 and then put ... indicating that this pattern, this trend is going to continue forever. Or we can put a bar on top. We can say this is 0.333, and this bar on top says everything that's underneath this bar is going to repeat. So it's 333, 333, 333, 333, forever and ever and ever. Another way of doing it is saying, well, you know what? 333 repeating is the same as just 3 repeating. And so I can just put a bar over the 3 if I want. So there's a lot of different ways to sort of let the reader know when they're looking at your math what's being repeated, what the pattern, what the trend is. I could have also just done this right here, 0.3 ... but that really doesn't get the point across that it's repeating as much. So at any rate, the bar notation is preferable because it really shows you what is being repeated. So I'm going to take an algebraic approach to this, and if you've never done algebra before, that's probably okay. You can maybe follow along here. You just need to understand that sometimes X stands for an unknown, something that we want to solve for. If you have some familiarity with algebra, then this is probably going to be okay for you. And there's another way of doing this. It's called a geometric series, and I'm going to save that for another video. So every single time I do one of these problems in this video, I'm going to do it with an algebraic approach. So here's the thing. I'm going to call X equal to 0.333 repeating. That's X. Just stands for that number. Now it's not unknown. What I'm going to do is I'm going to do some fancy math tricks to see what the fraction representation might be of 0.3 repeating. Now hopefully we all know that that's 1 over 3. That when I do this process, I should get 1/3. Let's see if that's what we get. I notice that I only have one digit that repeats. It's a 3, and then it's a 3, and then it's a 3. So what I'm going to do is I'm going to multiply both sides of this equation by 10. Now what happens when you multiply something by 10? Well, the decimal moves over. So I get 3.333 repeating. Now remember, this repeats forever. So I have an infinite number of 3's to draw from. And so by moving this decimal place over to the right once, I still have an infinite number of 3's going on here. Now let's look at this right-hand side here. This is 3 plus 0.333 repeating. Now this should look familiar. This right here, this 0.333 repeating is what I called X. And so if I rewrite this in terms of X, I have 10X from right there equal to 3 plus 0.333 repeating is what we called X originally. Now what I'm going to do is I'm going to bring all of my X's to one side. So I have 10 X's right here. I have 1 X right here. I'm going to subtract X from both sides. 10X minus 1X is 9X, and that equals 3. If I want to solve for X, I want to divide both sides by 9, and I get X equals, remember 9 over 9 cancels. Canceling fractions, simplifying fractions will be linked in the description below. And I get 3 over 9. And again, simplifying fractions goes in the description below if you need a refresher on that. But 3 is 3, and 9 is 3 times 3. And 3 over 3 cancel. That's a 1. And so I get what we expect. As a simplified fraction, we get 1/3. All right, for my next example, I want to look at 2.8 and then 33333 repeating. So it's again repeating 3's, so it's similar to the last problem. But the thing is that this 2 is not repeating and this 8 is not repeating. So what do I do with those? Well, for the time being, let's just write this as 2.8. Leave that alone for a little bit. Plus 0. There's no 3 in the ones or in the 10th spot, and so I'm going to put a 0 there. 3, 3, 3 repeating. So here's what I'm going to do. I'm going to set this thing right here equal to X. And so X is 0.0333 repeating. There's an infinite number of 3's following that decimal with that 0 smushed in between. So 10X is 0.333 0.33 repeating because I moved this decimal place over once. So I don't have my answer yet. 10x equals 0.3 plus 0.0333 repeating. Because 10x has a 3 in that 10th spot, and so I'm going to remove it. And again, the reason why I'm doing this is because this thing right here is x all over again. And so what I have now is 10x equal to 0.3 plus x. This looks very similar to what we did previously, but if I subtract x from both sides, I get 9x equal to 0.3. I can solve for x by dividing both sides by 9, and I get x equal to 0.3 over 9. Now that's not a very good representation of that number because it's a decimal divided by 9. Let's see what that looks like as a fraction. Well, we need to remember how to first convert decimals into fractions. That's a terminating decimal, and so that's the part 1 video. This is 3/10, and then we divide that by 9. And I'm also going to link up the dividing fractions video in the description below, because what this is 3 over 10 times 1 over 9. And so, what do I get? There's a common factor of 3 that I can cancel from the top and bottom. So I get 3 over 10 times 3 times 3. And so 3 over 3 is 1. And so what I get is 1 over 3 times 10, which is 30. So it's not 1 over 3, it's 1 over 30, because there's that extra 0, that extra placeholder that hadn't been repeated yet. And if you look, this is what x equals. My number that I'm trying to write as a decimal, as a fraction, is 2.8 plus 1 over 30. So I'm getting there. I've handled the repeating part of this. Now remember, 0.8 is a fraction. That's 8/10. Again, that goes back to my terminating decimals video. And so this is 2 plus 0.8, or 8/10, plus 1 over 30. And I'm going to link up the adding and subtracting video, adding and subtracting fractions video down below, because I need to know how to add 8/10 plus 1/30. That involves a common denominator. In this problem, that common denominator is going to be 30. To get from 30 to 30, I put a 1 up there. To get from 10 to 30, I multiplied by 3, so I need to multiply 8 by 3, which is 24. Again, if you need a refresher on that, link in the description below. So I get 2 plus 24 plus 1 is 25 over 30. Reducing this fraction, they both have a common factor of 5. This as a mixed number is 2 and 5 over 6.
Wow.
So as a mixed number, I get 2 and 5/6. If I want to convert this mixed number into an improper number, remember, you take the denominator, you multiply it by the whole number. 6 times 2 is 12, and then plus the numerator. 6 times 2 is 12, plus 5 is 17 over 6. Let's recap, because that was a lot of work. I want to represent 2.8 and then a bunch of 3s, an infinite number of 3s afterwards. I want to represent that as a fraction. So what I did was I took the stuff that did not repeat, and then I looked at the stuff that did repeat. I had to make this adjustment to get rid of this 0 here by multiplying both sides by 10, and then I peeled off a 0.3 because there wasn't an original, or in the original x, there was not a 3 in that spot right there. And so I once again broke this up so that 10x could be written as something that had x in it all over again. Again, notice that x has the 0 after the decimal and then a bunch of 3s. A 0, then a bunch of 3s. This thing is what I called x, so I subtract x from both sides and I solve for x as a fraction. All right, now let's look at 1.7474747474. Now there's not one digit repeating, there's 2 digits. 74, then 74 again, then 74 again. So I can actually write this as 1.74 repeating if I wanted to. So what I'm going to do is I'm not going to multiply this by 10, because 10 is used for when there's only one digit repeating. There's actually 2 digits repeating here. And so let's forget about the 1 for the time being. Let's call x equal to 0.74 repeating. I'm going to multiply that by 100 on both sides. Remember in algebra, what you do to one side of an equation, you must do to the other. So 100x equals, I'm going to move this decimal place over because I'm multiplying by 100. So 74 decimal right there. And what follows 74? 7, 4, 7, whoops, 7, 4, 7, 4. There's still, remember, an infinite number of 7474s after that. Right? So this is 74.74 repeating. Once again, why did I do this? I did this because this 74.74 repeating is 74 plus 0.74 repeating. We called 0.74 something. We called that x. And so this whole equation, this 100x, is really equal to 74 plus x. And now what do? I subtract x from both sides. I get 99x equal to 74. And I can now solve for x. I can divide both sides by 99. And I get x equal to 74 over 99. Now here's the thing. That's the fraction representation of it. We don't know right now, or at least I don't know right now, without some thought, whether or not that is a reduced fraction. That's usually a good idea to reduce your fractions. So let's look at the factors of 99. There's 1, but that's trivial. 3 goes into both, or I'm sorry, 3 goes into 99, but I know that 3 does not go into 74. And if you don't know the trick, if the digits of a number sum up to 3, then that number also is divisible by 3.
Wow.
All right, so 7 plus 4 is 11. But the thing is, 11 is not divisible by 3. So since 11, the sum of these digits, is not divisible by 3, then this whole number 74 is not divisible by 3. 11 goes into 99, but 11 doesn't go into 74. 9 goes into 99, but 9 does not go into 74. And that's pretty much it, except for 99 itself, which clearly does not go into 74. So this is the reduced fraction version of 0.74 repeating. But that's not the number. Remember, I still have this 1 out here that I need to handle. And so that's pretty simple. 1.74 repeating is 1 plus x, which is 74 over 99. So here's a mixed number version. As an improper fraction, I would take 99 multiplied by 1, which is 99. I would add 74 to that, which is 173, and I would divide that by the original denominator right here. And so as an improper fraction, I get 173 divided by 99. If you do the long division linked in the description below, to check your work, you will find that 173 over 99, or 173 divided by 99, is 1.74747474 repeating forever. All right, let's look at 0.123 repeating. Same sort of idea. But the thing is I don't have 1 digit or 2 digits repeating. I actually have 3 digits repeating. 1, 2, 3, 1, 2, 3. So if I call x 0.123 repeating, I need to multiply both sides by 1000x to move this decimal place over once, twice, thrice. So get 123.123 repeating. Once again, I have an infinite amount of 1, 2, 3, 1, 2, 3, 1, 2, 3s after this decimal place since it repeats forever. And so multiplying both sides by 1000 still keeps a 0.123 repeating on the right-hand side of that decimal. So what is this right-hand side? This is the number 123 plus the repeating decimal 0.123, 123, 123. Remember, at the very get-go, we called that x. And so I get the number 1000x equal to 123 plus, and let me make sure I put my repeating bar over that 1, because that 1 is still being repeated, 0.123123. That's x. I can now algebraically solve for x. Subtract x from both sides. I get 999x equal to 123. I can divide both sides by 999. And x equals 123 over 999. It's clear that 999 is divisible by 3. Is 123 divisible by 3? Yes, it is, because 1 plus 2 plus 3 is 6, and 6 is divisible by 3, So that means that 123 must be divisible by 3 according to that trick. Okay, so if I pull a 3 out of 999, I'm left with 333. And just real quick, if I do some long division, how many times does 3 go into 123? 3 does not go into 1, but 3 does go into 12 4 times. 4 times 3 is 12. Subtract, you get 0. Bring down the 3. And 3 is going to evenly go into 3 one time. And so on top, I can factor that as 3 times 41. And according to my simplifying fractions, 3 divided by 3 is 1. Those cancel. And I'm left with 41 on top and 333 on the bottom. And those are actually relatively prime. Nothing will go into 333 that will also go into 41. As a matter of fact, I know that because 41 itself is a prime number. And so nothing goes into 41 other than 1 in itself. And 41 certainly does not go into 333. So I know that I am done with that answer. So how do you represent the repeating decimal? Point, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3 forever. It's 41 over 333. And then for my last problem, I'm going to do something that looks pretty intimidating. Looks pretty intimidating because how often does this repeat itself? Well, I have to wait 1, 2, 3, 4, 5, 6 digits until I get 1, 4, 2, 8, 5, 7. If I call this thing equal to x, as I normally do in these sorts of problems, I need to multiply both sides of this thing by 10, 100, 1,000, 10,000, 100,000, 1 million. I need to multiply both sides of this thing by 1 million. So I get 142,857.142857. Remember, this is repeating. There's an infinite number of those things. 142,857. 142,857. An infinite number to draw from. And that equals 1 million x. X times a million is 1 million x. So the reason why I do that is because this is the number 142,857 plus 0.142857 repeating, and that equals 1 million x. Does that look familiar? That is x all over again. So I get 142,857 plus just regular old x by itself, because x is 0.142857 repeating, and that equals 1 million x. What do I do now? I subtract x from both sides. What's a million things multiplied or subtracting one thing? That's just 999,999 of those things. And that equals 142,857. And I am very intimidated and I'm very scared right now because those are gigantic numbers. What's going to happen? I don't know. I'm scared. I'm going to divide both sides by 999,999. And so x, I'll just save us some room here. This is what x equals. This 142,857 repeating is equal to that mess right there. Now I'm going to venture a guess that that's not simplified. I mean, if it is simplified, that's a pretty gross fraction. But I'm going to venture that maybe there are some things that cancel. So a good place to start is, well, you know what, let's do this. 9 definitely goes into the bottom. Let's see if 9 goes into the top. Let's just try that. We know how to do long division, and if you need a refresher, linked in the description below. So 9 goes into 142,857. Let's just give it a try. 9 does not go into 1, but 9 goes into 14 once. 1 times 9 is 9. Subtract, I get 5. Bring down the 2. 9 goes into 52 5 times, because 9 times 5 is 45. And I subtract and I get 7. And then I bring down the 8. 9 goes into 78 8 times, because 8 times 9 is 72. Subtract and I get 6. And then I bring down this 5. 9 goes into 65 7 times. 7 times 9 is 63. Subtract, I get 2. I'm running out of room, but just in the nick of time, I bring down that 7. And look, 9 goes into 27 3 times evenly. So these numbers are both divisible by 9. And so I can write x as 9 times 15,873 on top, divided by 9,111,111. It's very easy to see how if I pulled out a 9 from everything, dividing 9 into 9 is 1, 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 into 9 is 1. These cancel. I am on the path to success. Hey, I wonder if that's divisible by something else. Clearly, 3 goes into this bottom thing because 1 plus 1 plus 1 plus 1 plus 1 plus 1 is 6, and 6 is divided by 6, or is divisible by 3, and so that's divisible by 3. I wonder if the top is divisible by 3 as well. Well, let's just try real quick. Let's just use our little trick. 1 plus 5 is 6, plus 8 is 14, plus 7 is 21, plus 3 is 24. So the sum of these digits is divisible by 3, which means that this whole number, 15,873, is also divisible by 3. Let's do our long division and try it out. 3 goes into 15 5 times. 5 times 3 is 15. Subtract, I get 0. Bring down the 8. 3 goes into 8 twice. 3 times 2 is 6. Subtract, I get 2. Bring down the 7. 3 goes into 27 9 times evenly. 9 times 3 is 27. Subtract, I get 0. Bring down the 3. 3 goes into 3 once. Hey, look at that. 5,291. So now the top is equal to 3 times 5,291 divided by, now I know 3 is going to go into 111,111. So let's do that real quick. We'll do that. We're running out of room here. 111, comma 111. 3 goes into 11 3 times. 3 times 3 is 9. Subtract, I get 2. Bring down the 1. 3 goes into 21 7 times. 7 times 3 is 21. Subtract, I get 0. Bring down the 1. Now 3 does not go into 1, but 3 does go into 11. So I put a 0 there, because remember, 3 did not go into 1, so I put a 0 there. So I move over to the next spot, which is right above the tens spot. 3 goes into 11 3 times. 3 times 3 is 9. Subtract, I get 2. Bring down the 1. 3 goes into 21 7 times. And so I get 37037. And hey, look at that, some 3's cancel. This mess right here can be simplified down to 5,291 divided by 37,037. We're getting somewhere. I wonder if this is divisible by 3. Well, hey, look at this. 3 plus 7 is 10. 3 plus 7 is 10. That's 20. That is not divisible by 3. So I can't use that trick anymore. I wonder if this is relatively prime. Turns out it's not. Turns out 11 will go into both of these. And let's see. How many times does 11 go into 37,037? 11 goes into 37 3 times. 3 times 11 is 33. Subtract, I get 4. Bring down the 0. 11 goes into 40 3 times. 3 times 11 is 33. Subtract, I get 7. Bring down the 3. 11 goes into 73 6 times, because 6 times 11 is 66. Subtract, I get 7. Bring down that 7. 11 goes into 7 times. And so this fraction right here becomes, well, it has a denominator of 11 times 3, 3, 6, 7. And 11 also goes into the numerator. 11 goes into 5, 2, 9, 1. 11 goes into 52 4 times. 4 times 11 is 44. Subtract, I get 8. Bring down the 9. 11 goes into 89 8 times. 8 times 11 is 88. Subtract, I get 1. Bring down the 1. 11 goes into 11 once evenly, so boom, we're done. Hey, look at that. 11 divided by 11 is 1. Those cancel. And I'm still making progress. 481, 3, 3, 6, 7. Now, I wonder, since, this video is getting very long, if 481 happens to go into 3,367. I wonder. Let's just see. If it did, something times 1 would have to give me 7, right? That's how multiplying numbers works. And I'm going to link multiplying numbers in the description as well, just so you can see my thought process here. But I wonder, just curious, what 481 times 7 is. I wonder. Wouldn't that be awesome if that were equal to 3,367, 7 times 1 is 7. 7 times 8 is 56, so I put the 6 there, carry the 5. 7 times 4 is 28, plus 5 is, hey, look at that. 481 evenly goes into 3,367. So I can write this as 481 divided by 481 times 7. And look what happens. 481 over 41 is 1, and I get 1 over 7. Wow, that was a long process. The number 1 over 7, that very simple, very innocent-looking fraction, wound up giving me this mess of a problem right here. And that's just the game. That just happens sometimes. You got to be prepared for it. You got to have stamina. You got to just buckle down and do it. But when you do it, man, it is rewarding. And you can check. You can do long division, 7 into 1, and you will see that you will get 0.142857 repeating. Hey, thanks for watching. I really appreciate it. I hope you enjoyed this video. I enjoyed making it, especially that last problem. It was a doozy. Here are some problems for you to practice and work on. Let's see, I have 0.7 repeating, 1.2, and then here just the 4 is repeating. And I have 5.7 with the 2 just repeating, and 2.5, and just that 5 is repeating. So, thanks for watching. I really appreciate it. Tell your friends, like the video, subscribe, broadcast this channel everywhere that you possibly can. Spread the joy and love of mathematics. Hopefully you're getting the hang of this stuff and you're enjoying your mathematics courses a little bit more, or you're just watching this for fun and you're doing math as a hobby now, which would also be completely awesome. So, thanks for tuning in. I really appreciate it. Like, subscribe, keep practicing. Answers to these problems down in the description below, and I will see you next time.